Hi everyone, in this video on arithmetic sequences, we're going to work through this exam question in which we need to find the sequence's unknown common difference. And this is the second video in which we're dealing with an unknown common difference, but it's worth knowing how to solve this question as it sometimes appears as being a little bit more complicated than the previous one we saw. That being said, if you feel up for it, go ahead and press pause and try solving this before watching the rest of the video. Either way though, let's get started. Now I'll move this question to the side, like so. And as I always do, I'll quickly write SOL here for solution. Okay, here we're told, in an arithmetic sequence, the third term is 8, and the eighth term is 23. And we need to determine the common difference. Well, a good starting point is to make note of the information that's given. And the first thing to point out is that we're clearly told that we're dealing with an arithmetic sequence. Now this is important for two reasons really. The first being that it tells us that to get from one term to the next of our sequence, we're always adding the same amount, which is the common difference. And it also tells us that the general term, or the nth term of this sequence, is given by the formula for the nth term of an arithmetic sequence, which we've already seen was u sub n, the nth term, is equal to u sub 1, that's the first term, plus, in parentheses, n minus 1, times the common difference d. And I'll go ahead and box that formula. There we go. That's the formula for the nth term of an arithmetic sequence. And I should say before carrying on, this formula is often given in exams. For instance, if you're an IB mathematics student, this formula would be given to you in your formula booklet. That being said, I carry on. The next thing to make a note of is the fact that we're told that the third term is 8. In fact, I'll make a bullet point of that. There we go. We know that the third term, so u sub 3, is equal to 8. Following that, we're also told that the eighth term is 23. So I'll make a second bullet point of that. We know that the eighth term, u sub 8, is equal to 23. And of course, we're told what we need to find. We need to find the common difference, which remember is d. So I could even say d equals to question mark. Okay, so how do we actually find the common difference d? Well, there are two approaches really, and in this video I'll be showing them both. The first approach is to use the formula for the nth term, but I'll already say that's definitely not the quickest method. Nevertheless, I'll start by showing that before showing you a quick and easy way of solving this problem. And so what I'll do here is I'll sort of split the screen in two, like so. And so on the right hand side, underneath the formula for the nth term, I'll show how to solve this problem using this formula. And here's the whole idea. Since we know that the third term has to equal to 8, that tells us that when we replace the n inside this formula by 3 since it's the third term, the left-hand side has to equal to 8. And in fact, I'll go ahead and write that, and I'll put a little bullet point here. Since we know that u sub 3 equals to 8, this formula allows us to state that 8 has to equal to the first term, u sub 1, plus, in parentheses, 3 minus 1, times the common difference d, where, to be clear, all I've done here is apply this formula for the nth term to the third term. And so I replaced the n inside this formula by 3 for the third term, and I replaced the left-hand side, so the value of the term, by 8, which led to this. Now since 3 minus 1 is equal to 2, we can go ahead and state that this is the same thing as 8 equals to the first term, u sub 1, plus 2 times d, in other words 2d. Notice here that I've gotten rid of the pair of parentheses, and that's due to the fact that once I've calculated 3 minus 1, which is 2, the parentheses serve no purpose whatsoever. And so this is what we get from the third term being equal to 8. Next, I do the same thing again, but this time for the eighth term, which remember is equal to 23. And so I'll put a second bullet point here. There we go. We know that the eighth term, u sub 8, is equal to 23. And so copying this formula again, but this time we'll replace the n we see by 8, and the left-hand side here by 23, we quickly obtain 23 equals to the first term, u sub 1, plus 8 minus 1 times the common difference d. And since 8 minus 1 is 7, this becomes 23, which equals to the first term, u sub 1, plus 7d. Okay, now I'll go ahead and box these two equations. There we go, that's 1, and in fact I'll give them names. This is E1 for equation 1, and I'll box the second one right here, like so, and I'll call that one E2. Both of these equations contain the unknown we're trying to find. Indeed, they both have d inside of them. But we also notice that they both contain the first term, u1, and, well, we don't know what the first term is. And so the trick here is to realize that if we were to subtract the first equation from the second one, or even the second one from the first one, then we'd eliminate the first term and be left with an equation with one single unknown, which would be the common difference we're trying to find. Here's what I mean. If I go ahead and do equation 2 minus equation 1, and in fact I'll copy those equations again, if I start from E2, so equation 2, which is 23 equals to U1 plus 7D, and I take away from that the first equation E1, which was 8, which equals to U1 plus 2D, so that's E2, and this is E1. Subtracting the bottom one from the top one, on the left-hand side we'll have 23 minus 8, which is 15, and that will equal to the right-hand side, which would be U1 minus U1, which is 0, so I don't bother writing that, plus 7D minus 2D, which is 5D. And here we can clearly see that we're left with an equation with just one unknown, which is D. And so to figure out what D is, all we have to do is solve this equation. And since D is being multiplied by 5 here, to get rid of that 5, we divide the right-hand side by 5. But of course, we need to do the same on the other side of the equation. So we're going to divide 15 by 5 as well. And so the left-hand side becomes 15 divided by 5, or 15 over 5, which equals to 5 times D divided by 5, which just leaves us with D. Finally, since 15 divided by 5 is equal to 3, we can go ahead and state that 3 is equal to D. In other words, D equals to 3. And that's the answer. We've just seen how to find this sequence's common difference using the formula for the nth term of an arithmetic sequence. But as I suggested before, although what we've done here is definitely correct, and if you like this method, by all means use it, this definitely isn't the fastest way of solving this problem. And so on the left-hand side of the screen, let me show you a slightly different approach. Here we go. The idea here is to find an expression written in terms of 3 things. Those being the 2 terms that were given, so the third term which is equal to 8, and the 8th term which is equal to 23, and the common difference D that we're trying to find. And here's the whole idea. Although we don't know what the terms of this sequence are, nor do we know what its common difference is, we do know 2 of its terms. And of course, we also know that it's an arithmetic sequence. So no matter what, we know that for this sequence we'll have a first term, we'll have a second term, we'll have a third term which we know is 8, a fourth term, a fifth term, a sixth term, a seventh term, an eighth term which we know is 23, a ninth term, and so on and so forth. And we can be absolutely certain that to get from one term to the next of this sequence, we're always adding the same amount, which is the common difference D that we're trying to find. So we're adding D to get from the first to the second, as well as from the second to the third term, as well as from the third to the fourth term, and so on and so forth. And now what we notice here is that to get from the third term, which is 8, to the 8th term, which is 23, we add D 1, 2, 3, 4, 5 times. And in fact, let me write that. To get from the third term to the 8th term, we've added D 5 times. And so I could even write plus 5 times D, or just 5D. And so using that fact, we can quickly state that the 8th term, U sub 8, must equal to the third term, U sub 3, plus 5 times D. Where, to be clear, we're getting this 5D here from the illustration we made up here. Now replacing this U sub 3 by 8 and this U sub 8 by 23, this quickly turns into 23 equals to 8 plus 5D. And we can see here that we're left with an equation with one single unknown, which is D, which is exactly what we need to find. So all we have to do now is solve this equation. And for that, I'll start by getting rid of this 8 that's being added to the right-hand side, which I do by subtracting 8, and of course I do the same on the other side of the equation. And so on the left-hand side we have 23 minus 8, which is 15, and that's equal to 8 minus 8, which is 0, so we don't bother writing that, plus 5d. In other words, that's 15 equals to 5d. Finally, to get rid of this 5 that's multiplying d, we divide the right-hand side by 5, and we therefore do the same on the left-hand side. And so this becomes 15 divided by 5, which is 3, and that's equal to 5d, or 5 times d, divided by 5, which is just d. And so 3 equals to d. In other words, d equals to 3. And that's the answer. Now, looking at this method and comparing it to the first one we used, it's difficult to argue against the fact that this method is much more efficient. But you may be thinking it wouldn't be convenient to write all of this out if ever the two terms we were given were further apart. For instance, if I'd been given the 4th term and the 50th term. It wouldn't be convenient to write something like this all the way up to the 50th term. But luckily for us, we could have found how many d's we had to add, which in this case was 5, simply by looking at which terms we were given. Indeed, instead of writing all of these terms here to figure out how many d's we had to add, we could have simply made use of the fact that the two terms we were given were the 8th term and the 3rd term. And here's how. Since we were given the 8th term and the 3rd term, the number of d's we have to add to get from the 3rd term to the 8th term is simply equal to 8 minus 3, which, as you know, is equal to 5. And that 5 tells us how many d's we have to add to get from the 3rd term to the 8th term. And the same would apply to, say, the 50th term and the 9th term. So say, for instance, you were faced with a similar problem in which you were given the 9th term, so u sub 9, and the 50th term, u sub 50, then to figure out how many times you had to add the common difference d to the 9th term to get to the 50th term, you would simply have to do 50 minus 9, which equals to 41, which would then allow you to state that u sub 50, the 50th term, is equal to the 9th term, u sub 9, plus 41d, where in essence this result is the same type of result as we have here, which then allowed us to quickly find the value of the common difference d. And there we have it. All that being said, you choose whichever of these two methods you prefer. Many of my students like this first method, and that's simply because they like being able to fall back on this formula every single time they're faced with an arithmetic sequence. Of course though, if you're comfortable with the topic and you see the logic behind this method, then I simply can't argue with the fact that using this method is simply quite a lot faster. All that being said and done though, that's it for this tutorial.